Here's another example of solving an absolute value equation. Here we have the equation, the absolute value of x minus 12 equals 2x. The first step in solving any absolute value equation, remember, is to get the absolute value on one side. And we have that, so that's done. The next step is we're going to split this equation into two pieces to get rid of the absolute value. Because remember, an absolute value removes the sign on whatever it is taking the absolute value from. So if I want to remove this absolute value, I need to think about how this inside could have been a positive number. So x minus 12 could have been positive 2x, or x minus 12 could be the negative result before it was absolute value. So it could have been negative 2x. So we get two separate equations which we can then solve. When we solve this, we would want to get x by itself. Generally, when we have x on both sides, we want to move the smaller one. So I'm just going to move that x, negative 12 equals, well, when I move that x, I'm really subtracting it from both sides, so 2x minus x would be just x. So there I actually have x by itself. In the other one, just to be consistent, I'll move this x as well. We do get a different result when we move x in this case. Negative 12 is the same on the left side of the equation, but negative 2x minus x gives me a negative 3x. So here on this right side, we do need to continue to get x by itself. Simply divide out the negative 3 from both sides, so we get x equals positive 4. So we get two solutions. Remember, we want to check those solutions to make sure that we haven't made an error or a mistake. So let's check these. So I'll check them right underneath. So I always want to put the solution back into the original equation. So this would be the absolute value of x, which is negative 12, minus 12. Close your absolute value equals 2 times negative 12. And I can set up the other one the same way. To do the check, the absolute value of 4 minus 12, because x is 4, equals 2 times 4. Now in both of these, I want to simplify each side and make sure I get the same result. So going back to the example on the left, the absolute value of negative 12 minus 12, we'll do the inside first, so that's an absolute value of negative 24. And then the absolute value of negative 24 becomes positive 24. So that's what we would get on the left side of the equation. On the right side, though, 2 times a negative 12 is negative 24. So what I end up with here is a false statement. Okay, so this is interesting. Even though we did solve this correctly, we get a false statement. This is an example, just like we had with rational equations, of an extraneous solution that is coming up. There was nothing we did wrong in the process, but we got a solution that actually doesn't work back in the original equation. So this negative 12 is actually an extra solution, extraneous. And it is not a true solution. We can actually cross it out because it doesn't work in the original equation. Even though it worked at this stage, okay, after we got rid of the absolute value, it doesn't work all the way back. And that's because the absolute value removes the sign. And sometimes when you remove the sign, especially if you have an x on the other side, you may end up with an issue that arises. Let's finish checking the other solution we got, which was 4. The absolute value of 4 minus 12 would be the absolute value of negative 8. Calculating that left side, the absolute value of negative 8 is 8. All right, and then doing the right side, 2 times 4 is 8, and that is 8. So this side does check, and so we do find that the 4 is a solution. So if we were writing this as a solution set, we would say the solution set is, and then embraces 4. Okay, so there's an example where we actually had an extraneous solution to an absolute value equation.